Marche. Hello everybody. Welcome to my talk, and I'm Ange ALBERTINI. I will speak about the PE file format. Oops, I have to stay. So, I've been a reverse engineering for some time, and a few years ago I was ashamed by malware for which I couldn't understand the PE file structure. So I decided to go back to my studies, studying the PE file format from scratch, and I decided to share it on my website, following a few strict rules. So, for example, my website is called corkami.com. And I share with, as I said, strict rules. So for example, whenever I learn a new fact, I will create a proof of concept so that I'm sure this is how things actually work. And also I create all these proof of concept by hand from scratch, which means I'm not patching already existing files, I'm not using a generator or a compiler, so that I'm sure I control everything in the full structure. It's a bit tedious and will require a lot of extra work, but it's at least I'm in full control. So for example, I type my PDF files in Notepad, so this is a complete PDF, or I create the whole PE structure by outputting every byte of the file structure, or in this case, for a Java class, I created my own script to output the opcodes individually, so that I'm sure that this is how and why things actually work. And so that if every proof of concept is pinpointed on the fact that I'm studying, it's crystal clear because there is no noise coming from the generator or something else. And also important, they are clean, even if they are odd, they are not malicious, so they are shareable and they are not dangerous to share around. So this makes the Corkami a technical website. Also, I wanted to be nice with the visitors and to make easy access to everything, so there's no ads, login, or whatever. And it's everything is on my website is open source, using with a license that is reusable commercially. Everything is open source, including the documents and graphics. And I'm also trying to rely only on free tools for everything. So everybody can review and comment my work, and more importantly, they can suggest. So, for example, sometimes guys have a malware or a confidential file that they are not allowed to share, but still has something interesting, and they come to me and they know that out of it I will extract the interesting property, so that then it's available for everybody on Corkami. And also I provide the binaries because sometimes it's a pain to compile them. So if you're just interested in testing your tools, your emulator or anything, then you can just download all the proof of concepts. Just to give you an idea, right now I'm a bit more than 160 different PE files on Corkami. So if you are interested in studying it in details or testing your emulator for robustness or something like this, then just download them. It's just a single archive. So this makes Corkami free. And also, what's the final goal of Corkami? It's not to advertise for a specific company, it's for my own use. So I'm not trying to do something shiny or thing, I just try to do something useful so that I use myself as a reference, either to learn and remember or to teach other people. And the test set that I create, that all these files represent, it's meaningful because first it tests all the tools I ever tried, IDA, OLIDebug, Q, normal, and it's clean. While it's odd and it's really pushing the envelope and it's really unusual, everything is clean, so it's freely shareable, there's no boundaries. So, and also you cannot ask people just to review proof of concepts and to look at source code. So when I have enough proof of concepts, I start writing a wiki page so that tries to summarize everything, but I don't have so much time. All this is just a hobby I do once the kids are asleep. So the wiki page is so often outdated compared to the rest, and eventually when the wiki page has been live for enough months, then I submit for a presentation. And also, because sometimes you cannot ask people just to read text and whatever, I also focus on trying to make documents that I use myself as a reference. So whether it's opcode tables or graphics or posters, I also try to do some documents that are used to teach people. and that people would print, that I would print myself to give some documentation for someone instead of reading lines of code and source. So I believe that makes Corkemy useful. So the rules of how I wanted to share my knowledge on Corkemy is that it's technical, free, and useful. And I don't think I'm anyone special, so I think it's the best way I can provide and share my knowledge with the community. So first of all, I will start with an easy introduction on what's a P, but really lightly, and then I explain at least why I decided to create yet another doc, and then I will enumerate a few of the oddities, whether they're static or dynamic. The thing is, I can't cover all the 160 proof of concept on the website, and if you want to go for more, and if you have some tools to test or to learn, then go ahead on the website. So P file, portable executable, or the common object file format. Okay, the basics. P file is the Windows binary, so if you ever run one of these, then you actually executed a P file in your life. Actually, P files is executables, DLLs, and drivers, so it's used a bit everywhere in Windows. So if you take a Windows 7 system, live system, then you end up having a lot of modules loading at the same time in memory. This is just a standard, all the modules present on a standard Windows 7 system. P file format is also used to store pure data stuff. So for example, when you share icons, the icons are typically stored in a DLL that is used just as DLL icon storage. It's also used, for example, in Windows 7 and XP. Sorry, is that too close? Can you hear me like this? Or okay, sorry, so it was just too close. So it's also used for translation of the strings. So in Windows 7, the strings for all the text of the interface are stored in independent DLLs. They only have a resource section, no code, and all this is all the resources are strings. It's also used for keyboard layouts. So once again, no code, but it's used by how do you say? So this is yet another DLL that has no code and is used in standard by the OS. Funny exception is that fonts are not stored in the PE file. They are stored as standalone binary data file, except the old bitmap fonts, which are, even under Windows 7, stored in the outdated new executable files. So all these bitmap fonts are actually the new executable files, the files from OS2. So which you cannot execute and which is not executable anymore, but those fonts are still this outdated format. So the day someone found an exploit in this font, people will have to use the outdated parser in their security tools. So basically, PE files is really the universal Windows binary. And if you are not familiar at all with the PE file yourself, or if you know someone who's not familiar at all, I made this poster, which is a simplified explanation, but it's self-contained, so you can print it and download it. It's also, so it's available in English, German, Spanish, Japanese, Korean. The Japanese, Korean, a few of them are not available, but they will be ready. Korean, Polish. How do you say the title? Thank you. I don't know how to say the Korean one. And actually, if you're familiar with PE file formats, you maybe already know the OpenRC poster, which was made by Eero Kaira. And one thing is, this poster was always available online, but his next two posters were only available commercially. So here they are. They are not available for yet. He is planning to rework on them, and he accepted that I mention, if you're interested in those posters, he accepted that I mention it at my talk, so that you give him pressure, so that you make him move the higher priority, so that he release them. So he made an improved layout for a poster and also a PE header walkthrough. So he plans to release them. If you want them, tell him. And he said he was okay with me doing so. So if you, once again, if you need an introduction, an easy visual introduction, I also supplied the file I made is, the file that is being analyzed is available on the website so that you can actually see it yourself. And you can, all the elements are described so that it's an easy introduction for the format. Oops, what's wrong? Oh yeah, any questions so far? Okay, because now we are going to leave the easy part. So now I will, if you're if you were not familiar with PE, now it's gone, and I will not go detailing every element of the PE file format because we'll switch to the bit extreme side of the PE file. So my other page is the advanced page where I try to summarize all of my findings, even if it's a bit permanently outdated. The proof of concepts are a bit more up to date. So the important thing is I'm actually interested in what the OS actually allows and not what the incomplete specs of Microsoft or any other documentation is about. So, of course, there is an official Microsoft documentation that is pretending it's not pretending anything. Okay, so I won't spend a lot of time on it. So, for example, 2 easy examples. It says that the size of optional header is actually the size of the optional header. The size of the optional header being constant, it means it should be a constant. And just another one, that Win32 version value is reserved and must be 0. Okay, so 2 of my proof of concept. One of them actually use the size of optional header that is 0, and it works. And so it means the section table is overlapping the optional header. And here I have one of my other proof of concept is actually a size of optional header that is longer than the file itself. So thank you, Microsoft. And for the Win32 version value, it can be non-zero, and it's actually interfering with the process, and it's actually used in malware. So basically, this is interfering with the actual version that will be reported by the OS on the PEB. So basically, if you modify Win32 version value, then a call to get version will give you this funny version number that is coming from the version from Win32 value. This is actually used in malware. So as you can see, if you rely on this documentation, you're bound to fail. Of course, well, maybe I was thinking maybe there would be a private, confidential, Microsoft-only documentation, but I discovered recently that Windows 7 App Locker is rejecting some files. So first, the message is funny because it's an App Locker is not a valid Win32 application, so already the error message is funny, and it's rejecting files that are perfectly working, thinking it's not even valid, while they perfectly work. So in here, this is a bug that I found last month in App Locker. It rejects PE files just based on the linker version, which is absolutely meaningless. So I have no idea why they would say it's not valid while the files are perfectly working. So at least if there is a perfect documentation, it's not at Microsoft, because otherwise such a incredible weirdness wouldn't happen. So of course there are other documentations on the PE file format, but what's lacking is that most of them are based on existing files. So they say, oh, I never saw that field in use or something like this. And most of the time you only get a web page with picture, not the actual proof of concept that run and that will save you time, or that will make sure, because sometimes the text is not so strict, not so understandable. So at least when you have the proof of concept, you know this is how things work. And when usually they are either very limited or messy, like patch files, or they are private and you have to contact the person and everything. But I don't claim that Core Commis documentation is perfect. The first reason of that is only it's a hobby, and I don't focus on explaining everything, even if at some times I was considering writing a book on the PE file format. But at least for now, just highlight oddities via my various proof of concepts. So just to make sure, usually in people's mind, a standard PE file has sections, entry points, and imports, and it's possible to do a proof of concept that has no section, no entry point, and no imports, and that just has code that is running. So if you are following the standard model, then your parser, when you analyze a file, you're bound to fail. It's with malware, of course. Compiled files, of course, are standard and clean, but it's not my focus here. So I'll start with the static oddities. I discovered that the most basic PE is not executable PE in the OS. So because you can have those for the resource and icons and stuff, you can have data files PE. So the PE files that are loaded via load library with a special parameter saying it's a data file. It has to be a PE. It will fail if it's any kind of binary, but it can be just a PE in the most strict meaning, which means just MZ, LFA new, and the P signature. That's it, and then it's accepted. So it doesn't even have a magic, a machine, image-based alignment, all these kind of things we think are standard. So if you want to hook at this, make sure that the PE file is different. So basically it means the parser is different from the standard ones. And even if you don't even specify it's x86 code or anything, it can contain code, and you can execute it. And another trick is that because P doesn't even have to be full, you don't even need a 0, then you can make a non-null PE file that will have code executed. So it was a request from Yvan Le Fou. It's not possible as a standard executable binary, but as a data file binary, it's possible to do a non-null. And because all the rest is not taken into account, you can very easily break all the parsers because all the rest all the other values are ignored, and the headers themselves can be truncated. I mean, either you truncate the PE signature, either you don't need to go anything beyond LFNU. You just need 1 byte of LFNU for it to work. So then I was wondering, what is the minimum requirement for those P that actually contain resource? So the data P, typically they have a resource. And it's pretty fucked up again, because everything can be full of -1, and you can still do a load library and find resource and load the resource and use the resource correctly, and you just need PE, optional header, magic, size of headers, and resource. The rest is completely fucked up. You can see I declare -1 or 65K of sections, which are, only the first section is meaningful. So if your parser, or if you're relying on that to see if the file is valid, then you're bound to fail because it just works, even under 7. So at least, well, I must admit that these files are a bit unusual, but still, if you hook that, or if you have an entry, or you can, how do you say, during an intrusion test, you can put your own file on the load library like this, X, then maybe you have a backdoor that people wouldn't expect. But at least back to classic P is the one we declared code, because the others could still contain code that is not officially declared as assembly. So all the DOS header is still present under Windows 7 64-bit. And I was just wondering, because there are still many XP files in the wild, usually this old 16-bit DOS stub is just printing a message and exiting. But I was wondering what are the actual available possibilities of that header. So one of my proof of concept is actually a broken P. So P-wise it's broken, so the DOS stub will open, they will be executed, and the DOS stub is actually loading the file itself, patching itself, and launching itself again. So at first launch, this is 16-bit code, it patches itself, and then this is the PE file code that is executed. So this line is shown by 16-bit DOS stub, and then it's executing itself again. So if you customers still have XP, then it might be a way to get in, because most tools will say this is not a PE file, it's not executable. Well, it is, and it's recovering itself. But it's recovering itself on disk, so there will be an image that could be detected. But still, it was surprising, because if you think about it, all those files were not allowed to execute PE files. That didn't exist in the past. So I don't see why a DOS file could execute a 32-bit file, and it's just fine. I think it's a bit of a danger, but XP is outdated, so. Image-based is pretty standard. Must be multiple of 10K. Well, thanks. One funny thing is that the error message, you cannot collide with the DLLs, the system DLLs. And if you see, it's a bit blurry, the error message are completely different depending on the OS. So for example, if you collide with NTDLL, the error message says the subsystem needed to support this image tape is not present, which is absolutely meaningless, because it's actually something like it's illegal system DLL relocation. So it's actually funny that for 4 collisions, every time you get a different result on the 2 versions of Windows. So I wonder what is their policy there. Another thing is that it's absolutely no problem to have an image based in kernel for user mode, provided you have a relocation. This is not a perfect trick, but I found a CV like this. I had to install a security software, and I just happened to run one of my PE, normal, and then I got a blue screen. Okay, so guys, be careful of your image base when you're in kernel mode. Entry points, there are many tricks with entry points. The entry points being at 0, it's classic thing. The entry point being virtual. So in this case, the entry point is before, it's not on the physical image, it's 1 byte before the virtual image. So virtual 0 will be used to encode some stuff. So this can break some loaders, because the address of the entry point is not physical, it's virtual. So this can break emulators and programs. Actually, there's absolutely no check on the entry point itself. It can be just anywhere in memory, and it's just executed blindly. So if your TLS is allocating the memory space or the how do you say? Or it's a DLL that is placed at this place, or you can directly call kernel APIs, system APIs that way. There is absolutely no check on the validity of the entry point. I think that shows how fucked up the Windows loader is. And then TLS is executed before and after entry point. So if a TLS is actually triggering exit process, then the entry point will never be called. Subsystem itself, no particular tricks. Sometimes you ask if there are any tricks. There are no magic trick with the values, just to say that it's the last required element to be present. If it's 0, the file will not work. But there are no requirements between a driver and a standard PE file, which means you can just to be sure, I made one of my proof of concepts is actually a file that is working in all the 3 subsystems. So if you just change the subsystem and you load it, it will work accordingly as a driver. It checks, I am in kernel mode, I am in user mode, and then it locates the imports and everything, and it also works as GUI or a console. So there's no, besides the low alignment, there is no difference between a driver and a PE file. And that's also, that enabled me, sometimes malware packers for drivers are a bit simple in what they do, but usually they are, being a driver mode code, it's a bit annoying to debug. So because the only difference is the subsystem, if you change the subsystem, you could load it in only debug or a user mode debugger. The thing is, the imports will not resolve if the driver has imports. So for that, I created a fake NTOS kernel that actually tries to, that redirects standard kernel mode APIs to user mode. So basically, it's possible to take your driver, patch the subsystem, use fake NTOS kernel, and load it with only debug, and still be able to debug some code. And this was used for the public CTF last year at the NUDIHack. Sections, there are many tricks, but I won't enumerate all of them. So there can be no section in a PE file. There can be up to 96 under XP and up to 64K under Windows 7 and Vista. You have several tricks. I can't enumerate them all, but one of my favorite section tricks is this one. So do you like this section table? It actually works. So basically, in low alignment, only the first section is really taken into consideration, so the rest is complete garbage, and it just works fine. So it's actually pretty difficult to, I know this file is extreme, but it would be pretty difficult to determine if it would be runnable or not, if it would run or not. So now let's move on to the dynamic oddities. During the loading process, all the headers are passed on disk, and the data directories are passed once everything is mapped into memory. The consequence of that is that if you play the trick and you overlap the section overlap the data directories, so the headers are the same, but the data directories are overlapped, you can get some funny data directories. So when the attacker is making ASCII art with the data directory, you can decide there is something wrong, but it still works, and this idea is actually coming from reversing labs. And there are other possibilities where some data are actually taken into consideration after loading. So basically, you have non-existing bytes, but when they are filled with zeros, then the structure becomes valid, while they were not present on the physical size, on the physical file. TLS is probably one of the most fucked up parts of the PE file. So TLS, it's a list of callbacks that are executed one after each other, but the list can be updated on the fly. So for example, here you have first TLS that puts the second TLS in the list, so the second TLS will be executed. TLS, thread local storage, are executed on thread start and thread stop, which means before the entry point and after exit process. So there is it's known for before entry point, so entry point is not the first point of execution, but also you can have an exit process and then the code is still actually doing something. And another thing is that TLS can trigger unhandled exceptions. Unlike the entry point, a TLS can just do something completely garbage, trigger an exception, and then the entry point will be executed just fine. So it's actually created a few other bugs in emulators and stuff. TLS can actually be located to import so that you get a free import call before the actual, the actual execution of anything else. And because imports are not resolved on the file, it's actually a bit hard to see on the file itself. TLS, like the DLL main, has tricky execution condition. I think this bug was fixed in IDA 6.3. Basically, after you return from TLS, only ESI has to be valid. So basically here, one of my proof of concept completely fucks up the registers. It was generating a crash in IDA. And also one thing is that one of the elements of TLS, the address of index, is, as it says, a pointer to an address that will be replaced with an index. That means it's not, I don't think it's documented by Microsoft. It means on the first TLS load, the address that is pointed will be replaced with zeros. So you can already place some kind of dynamic obfuscation there. And then on the next TLS, it will be replaced with 1. And one funny thing is that it happens differently whether you are under XP or under Windows 7. So basically you can have, one of my proof of concept is you can have a working file that is working on both, but the loading order being slightly different, the actual way the file is loaded is different on two OS. So I already showed that they are the data file PEs and the binary PEs, but also PE files can be different, whether they're the same PE file, whether they're run under Windows 7 or Vista or XP. So, and it's actually even, there is even a further difference with Windows 8. So, I think a perfect, and that doesn't exist, at least not yet, a perfect PE parser and mapper should ask which version of Windows do you want me to map as, and okay, I know it's a bit extreme, but I think it's better to know that before someone does it for you on your network. Relocations, okay, nothing so surprising, just rebase code when it has to be loaded at a different image base than the one in the header. Relocations are not used in 64-bit code because you can have RIP, the relative code. One of my proof of concept just used that just to be sure this works. But it's still funny that the system DLLs on 64-bit still contains relocations, but with empty tables. Okay, we have artifact from the compiler. A funny thing is that the relocations are totally ignored if they are not needed. So they could be present on a PE file, but if there is no relocation needed, the structure is not parsed at all, which can still create a few bugs with some software that actually still try to parse them, even if this completely bogus relocation information is not used for loading. So it could be a trick the other way, just to be sure you are in an emulator or a real system. Of course, if you know in advance where the code will be relocated, it's possible to have relocation encryption, but it's also possible to relocate code manually. So here the image base is in kernel, but I know where the code will be relocated, so my code is pre-relocated, so there's no relocation, it's a kernel-based image, and it works because things just come in place at the right moment. So another failure in a few emulators. And our relocations, so if you know where the file will be relocated, you can predict what the relocations will be. So you can actually encrypt code with relocation. So that's nothing new, and that's used in malwares. The relocations can apply to the relocations itself. So my proof of concept in the core commit is actually the relocation are decrypting the next block of relocation, so that you really have to make that things dynamic. And one thing is funny is that unlike all the other what the documentation says on the internet, MIPS relocation are still perfectly working under Windows 7, even if you're under x86 OS and the PE file itself is declared as x86. So this is still not supported by IDA 6.3. I understand that they don't want to support that because it's odd, but at least just do you know that it could be used in a malware and then it could work just fine. Relocation on image base, it's a funny one. Of course, the image base shouldn't be by default relocated because this is what the OS itself relocates, but the image base itself is used then for the calculation of the entry point. So here the entry point has a bogus value, and the image base will trigger relocations, but one of the relocations is actually applying on the image base itself, so it's not applied on disk, so this is not interfering the mapping, but once it's in memory, relocations will be applied, image base will be modified, and this will shift the entry point to the right place. So even if the RVA of the entry point doesn't correspond to what you have here on the file, it works just fine, because once again, things fit in together. And just one last, how much time do I have? I don't know, let's see. Oh, I'm early, okay. One last, and this is actually a funny one because I still don't have the explanation for it. Oops, sorry. If you play tricks if you play tricks and the section is actually in the middle of the file, and why stuck? There's something going wrong here. Why the stuck? Okay, there's something going wrong. Weird. Oh yeah, it was odd. It moved. The section alignments are a bit big, and then the problem is that I cannot scroll down. Oh, yeah, sorry. So basically, the section is bigger than 10,000. So only this should be totally loaded in the file, and because of the section characteristics being in the header, then I don't know why it's not related to the alignments, and it's not related to the sections, to the how do you say, the characteristics of the sections and to the characteristics of the PA, but only the end is loaded, and at 1000 there's nothing loaded anymore. So of course this proof of concept checks that one value is present and the other is not. So that I still don't have the explanation for that one. It was highlighted by Peter Ferry, and I'm still not sure why only 1000 of it is loaded, because it doesn't correspond to anything about the section characteristics or the PE file characteristics itself. So it looks like I still have a lot of time. I'm way too fast. So a few other ones then. I didn't. One thing is funny is that you can have a DLL that doesn't have the file is DLL set. It just works, but in this case, the DLL main is not executed. And it's actually quite funny because this is how Oli debug determines if the file is a DLL. So basically, you have a P that cannot be loaded because the DLL main, the entry point, will not be used. Here, it's bogus enough, and the how do you say, the DLL, no main, no entry point is executed, but you can still export it fine, and it works. So Oli debug is using file is DLL to check whether it's a DLL. So this file cannot be loaded by Oli debug, and on the other hand, for a PE file, for an executable file, everything can be set except file is DLL. So all these usually not relevant files can be, flags can be set for the PE file, but not file is DLL. Another one that I play with and shows some discrepancy between the documentation and the various versions of Windows. I was playing with a file version. So the version information is not correctly, the structure itself is defined by, in the Microsoft documentation, but it's not very clear whether it should, where in the file it should be. So it's possible to make the tab of version appear, but then there is nothing here, or there is just a bit of information, and this actually generates a crash under Windows XP. And it's even better because it crashes, then Dr. Watson kicks in, Dr. Watson crashes, and then he kicks in, and so on. So it's actually pretty funny. It was a bug. Of course, it's XP, so it's a bit outdated, but, well, it shows that Microsoft really doesn't have a correct documentation because they have assumptions about the file version that are not even written in the official specs. And then it's possible to play and create completely crazy values, even duplicates. So there are lots of possibilities. And it also depends on each version of the OS. Oh yeah, not PE file related, but this is the most important file in my in Core Commit, I think. It's a file that works both as Java and JavaScript. So if you have someone that pretends it's the same thing or who doesn't want to understand the difference, then you can say this is the same file and it works. I think that's the most valuable file in Core Commit, even though it's not PE related. I think it's definitely worth it. So I'm ahead of time. Any questions so far? Okay. What the? Oh, sorry. I'm ahead of time. That wasn't expected. So this p.rar is exactly the same as you can download from the Core Commit website. So the sources and the binaries, the compiled binaries are on it. So delay imports are completely, I can show it, so I make correct delay imports. Delay imports is a completely, external, it's a fake structure basically. It has nothing to do with the P loader itself. It's just a structure that is here to beautify the imports, but it's really fake imports. It's because it's actually code being handled by the debugger. So the important thing is that actually it's not used by the DLL at all, by the loader at all. So if you create completely fake delay import structure, tools will report bug and possibly crash. Oh, only one. No, it doesn't crash anymore. It's a new version. Okay, that's good. And it's also big. The problem is that because it's how do you say? Because it's still used by the disassembler to beautify the code, you can actually make it pretend that it's a fake structure, but it's not. It's this is completely irrelevant for the actual process of execution. It's not just a beautifying structure that is not relevant on execution itself. So it's actually something I would rather ignore because it could generate failures, and it's usually only used by clean compilers anyway. Bound imports. Bound imports is the fact when you can when you have a DLL and instead of how do you say? Instead of having a RVA to the actual name of the string, you actually put directly the timestamp of the DLL and the how do you say? And the actual address of the DLL. So it makes up. It's made to be how to say, to make imports loading faster because the potential RVA, not RVA, the potential virtual address of the import to be imported is already present. The thing is, you can actually fake it, and it's actually a way of tricking stuff. So basically, this is a standard one, and if you modify manually one of the, oops, did not work. Yeah, so you can actually modify that cell to have it redirected, and under XP, it was even possible to redirect to another DLL. So it's then calling another DLL. So it's a way for malwares to actually redirect in execution. For DLL forwarding, you can also forward loops for forward imports from one, how much time? C'est fini? You can actually forward imports from one DLL to the other, and you can also actually make loop. Oops. So I don't know if you can see, but you can actually redirect. So here you can, if you're not careful about forwarding imports, you can actually redirect yourself again, or you can redirect and do a cross, or you can loop here, loop once again, and do, so the fake exit process is actually going here, then here, then here, so it's actually able to break a few emulators and tools. Okay, I'm a bit too tired, so I will stop there. Yeah, well, many stuff. So if you want, it's probably better to ask me afterwards because now I'm a bit too late. I'm a bit too tired. So my conclusion is that the PE file is a mess. There are different parsers on the OS. It's on a single OS, and then the parsers are behaving differently on various versions of the OS. No, there is no tool or documentation that can claim to be perfect. A good thing is that Reversing Labs which is very good also in P studies and writing tools, is actually about to release an open source library that will be able, that should be extremely strong to parse and handle PE files. They asked me to review it. Also PE file, the Python library by Arrow, is pretty strong. There are still many unknowns, but at least a lot less than after I started, I think. And once again, if you want a simple introduction to the PE file, then you can have this URL, and then you have the complete URL with the hundreds of proof of concept available for everybody to test, try, have fun with, show your kids, and etc. So, any questions?
Did you try your PE trip on complete software?
Well, yeah, that's why I had a few CVs and bugs, yeah. I didn't try all of them, but I had a few messages from from the vendors and stuff. I don't have so much time. I just tried it accidentally sometimes. I try it intensively on IDA and everything, but not on vendors in general. But yeah, some of the PE files are just so weird that it's just normal that they are not recognized as PE files or whatever.
Did you have control problem then?
With the file? With the tools, security tools? Yeah, crashes, failures, yeah. With the such section tables, what do you expect? Any other questions? Okay, well, thank you.